All right, today we're going to crack open a classic case from the world of data. It's a bit of a cautionary tale, one that really proves why sometimes seeing is the only way of truly believing.
So, let me ask you a question. It kind of sounds like a riddle, right? When are four different stories exactly the same? I mean, how could four completely different situations, four totally distinct data sets, end up looking identical on paper? It seems impossible.
And the answer is when you only look at the numbers. This is a huge trap in data analysis. When we try to boil down all this complex information into just a few summary stats, we risk missing the real story completely.
I mean, just look at how convincing this is. We've got four different data sets here. And on paper, their key statistics, the mean, the standard deviation, even the correlation between X and Y, they are all pretty much identical. Based on this table, you'd be totally forgiven for assuming these data sets are basically clones of each other. But are they?
Okay, so to solve this mystery, we need to stop thinking like number crunchers and start thinking like detectives. We need a whole new philosophy.
And this idea, it comes from the brilliant statistician John W. Tukey. He basically argued that our role isn't just to calculate things, it's to investigate. We're supposed to be looking for clues, for evidence, for the real story that's hiding inside the data.
And this is his philosophy in action. It's called Exploratory Data Analysis, or EDA for short. Now, the crucial difference here is that EDA isn't about forcing our own assumptions onto the data. It's the exact opposite. It's about letting the data speak for itself, and we do that mainly by using visual techniques.
So the goals here go way beyond just finding the average. A data detective wants to uncover the deep structure, to spot the weird anomalies or outliers, and to really challenge the assumptions we might have brought to the table in the first place. It's all about getting true insight. All right, our detective has a philosophy. Now it's time to pull out the magnifying glass, which in our case is the scatter plot, and crack this case wide open. Let's see what those four identical data sets really look like. And here's our first piece of evidence, data set 1. This looks pretty much exactly how the statistics described it. You've got a clear linear relationship with a little bit of noise. No surprises yet. This is our baseline. But, whoa, look at data set 2. The numbers were identical, remember, but the picture is completely different. This is a perfect curve. Trying to force a straight line model through this data would be a huge mistake. The summary statistics completely lie to us about the underlying pattern here.
And this one is brilliant. It perfectly illustrates the power of an outlier. Dataset 3 shows an almost perfectly straight line, but it's being totally distorted by that one single point way off the mark. That one outlier is single-handedly pulling the correlation and the entire trend line away from the real story.
And finally, the most dramatic reveal. In dataset 4, almost all the data points are just stacked up vertically. The only reason a relationship appears in the stats at all is because of that one extreme point way out on the far right. The source calls this wagging the dog, where one single point basically creates the entire statistical story. It's amazing. So, case solved. 4 sets of numbers that looked identical were actually telling 4 wildly different stories. The key wasn't better math, it was a better process. It's all about when and how we choose to look at our data.
The classical way of doing things often looks like this. You get your data, and you immediately impose a model on it, say a linear regression, and then you do your analysis. You basically decide what you're looking for before you've even really looked.
The EDA approach makes one simple, but honestly revolutionary change. It just flips steps 3 and 4. You get the data, and then you analyze it visually. You explore it, you look at it from different angles, and only then do you choose a model that actually fits what you see.
And this really gets to the heart of the difference, doesn't it? Summary analysis is passive. It just reduces what's already there. It's focused on the past. But EDA, that's active and forward-looking. It uses data as a window to really understand a process and make better decisions for the future.
So what's the final verdict from our data detective? What's the one crucial takeaway from this whole investigation?
The verdict is simple. Numbers can be liars, or at the very least, they don't tell the whole truth. True insight comes from looking. As we've seen, graphics aren't just pretty pictures. They are the most powerful tools a data detective has for revealing the story hidden deep inside the numbers. So the next time you face a spreadsheet or a statistical summary, remember this case. Your numbers are telling a story. The real question is, are you sure you're reading the right one?